Hello everyone. In this video, we are going to study about the measurement of the rainfall. Then, what are the different techniques with the help of which we measure the rainfall? So let's start. So, when we talk about the precipitation, the major form of the precipitation in which the water that reaches the earth's surface, that is in the form of the rainfall, and that's why usually we replace the precipitation term with the rainfall. So this precipitation that is measured in terms of either the depth, that means for a certain area up to what depth the water is collected, that is one way of measuring the precipitation. The other way can be in terms of the volume, which is in cubic meter. Now, other than the rainfall, if there is other form of precipitation, that is, for example, snow or the hails, then for that correspondingly equivalent water depth that is considered. Now, how do we measure that rainfall? So this rainfall that is measured with the help of an instrument which is known as the rain gauges. Now these rain gauges are also known as the pluviometer or hydrometer or the ombrometer. All of them are one in the same thing, but the most commonly used term that is related with the measurement of the rainfall, that is the rain gauges. Now, when we are installing the rain gauges to measure the rainfall in a certain area, following guidelines are to be stuck to. Now, what are these guidelines? So this rain gauge that we are talking about as an instrument to measure the rainfall, that is nothing but a bucket type structure. So just consider this simple bucket. Now the water that will be collected within this bucket in a certain time frame, that will tell us the amount of rainfall that has occurred in a particular area. But when we are collecting the water in this bucket, the area in which it is present, this rain gauge must be surrounded by an open fenced area of at least 5.5 meter from both the sides. That means the area which is encompassing the rain gauge, that should be of a square shape having a side of 5.5 meter. Second guideline is that no object should be near the instrument. That means any obstruction which is present, that should be away by at least 30 meter or double the height of the obstruction which is present, and if both of them are counted, then we will take the maximum of these two values. The next point is that the ground should be perfectly leveled on which this instrument is placed. That means the level at which this rain gauge is present, that must be horizontal surface, so that the water which is collected, that is also representing a horizontal surface. Otherwise there would be some error. Then the fourth point is that the rain gauge must be seated near to the ground as far as possible. It should not happen that, let's say this is the ground level and you have provided the rain gauge at this height, and now here you are placing this bucket. So as we move away from the ground surface, the wind intensity that increases, and because of that there will be chances of toppling of this bucket. Therefore, to reduce the wind effect, the rain gauge must be seated as near to the ground as possible, but it must be sufficiently high so that if tomorrow there is any chances of the flood, then also this rain gauge must not be submerged into that flooding water. So it should be sufficiently high to prevent the flooding action. So let's say these are the four rain gauges. So one by one we will discuss all the four conditions. So the area in which it is encompassed, that should be a square of 5.5 meter, and it should be perfectly fenced. That means the wiring must be placed here so that no animal can enter into this area and could not do any harm to the rain gauge. Second one was no obstruction. Now that may be in form of a building. Let's say this is a building which is present, and let's say the height of this building. Okay, so usually one floor is at 3 meter. So let's say this is 10 floor building. So let's say the height of the building is 30 meter. And the second obstruction is a tree which is having roughly, let's say, the height of 15 meter. So the placement of this rain gauge that should be decided in such a way that the distance from the nearest obstruction that should be either the 30 meter or twice the height of the obstruction. Now in this case we have assumed that the building that is present, that is of 30 meter height. So we are having these two values. So out of these two, the maximum distance is to be taken. So one is 30 meter, another distance is 60 meter. So the maximum of two is 60 meter. So the distance of the rain gauge from this building that must be at least 60 meter. Similarly, the distance of the rain gauge from the tree that should either be 30 meter or 2 into 15 meter. Now in this case, both of these distances, they are coming to be equal. So that means the distance of the rain gauge that must be at least 30 meter. That is how we calculate the positioning of the rain gauge. The third condition was that leveled surface should be present below the rain gauge, because if this is inclined, then the water which will be falling into this, that will be corresponding to the area which is at an inclination. This is an effective area, while the actual area should be like this. Therefore there will be some abnormalities in the values which we will be getting. And the fourth one was regarding the level of the rain gauge, that there should not be any wind effect, it should not be as that high, and it should not be as low that there are the chances of the flooding of this rain gauge. Now we have discussed that the rain gauge is used for the measurement of the rainfall. Now what type of rain gauges are we having, and how does it help in getting the values of the rainfall? So one by one we will discuss about them. So what are the different types of rain gauges? So rain gauges, they are broadly classified into the two categories. First one is the non-recording type rain gauges, and second one is the recording type rain gauges. Now obviously the name itself suggests that the first one, that will not be recording any data, while in the second case the recording will be available. Now the non-recording type rain gauge, that is also known as the Simon's rain gauge, and this is the most commonly and widely used rain gauge in India of this category. That means of the non-recording type rain gauges, if let's say there are number of rain gauges which are present, this Simon rain gauge is the most popular in India. And the details of the installation about this non-recording type Simon's rain gauge, they are provided in this Indian standard of 4986, which was published in the year of 1968. Now what are these guidelines? So this diameter which is present at the top, that is of 12.7 centimeter, or that is also known as the 5 inches diameter, and this rim is present 30 centimeter above the ground level. So this is the ground level which is being represented by these hedged lines, and certain portion is concreted. So this is the concreted portion, which is the masonry foundation block, having the dimensions of 60 by 60 by 60 centimeters. And in this masonry foundation block, the rain gauge is inserted and it is concreted in this masonry block. Now this rain gauge, it consists of a funnel through which the water is getting collected into this glass bottle, which is of 7.5 to 10 centimeter diameter, around this glass bottle we are having this one metal casing. So the funnel discharges the water into this glass bottle, which is further discharged into this measuring jar. So one by one person will be required to empty this glass bottle into this measuring jar, and once we reach the end of the rainfall, we will get the height of the rainfall which is collected in this measuring jar, and that level of the water that will tell us the amount of rainfall in that particular area. Now there are certain demerits regarding this method. What are those? Now obviously when we are collecting this rainfall into this measuring jar, so one by one a person will be coming up and he will be emptying the glass bottle into this measuring jar. So we will be getting the level of the water, but in what duration, that we will not be getting. So that means this method gives only the magnitude of the rainfall, but it does not indicate that what was the intensity of the rainfall. That means it does not give the centimeter per hour of the rainfall, that in 1 hour how much centimeter of the rainfall has fallen. That is not revealed by this method. Second drawback is that this receiving bottle that we are having, it does not collect more than 10 centimeter of the water. Now if there is a heavy rainfall, then it will be getting filled up very quickly. Therefore this needs to be emptied frequently, and therefore frequent readings are to be taken. That's why this method is not used in case of the heavy rainfall. Now to maintain the uniformity so that we get the 1 day data, usually this reading is taken at the 8 hours and 30 minutes in the morning every day, and that is reported as the rainfall of the particular day. So that means every day at 8:30 a.m. data will be collected, and that will be regarded as the rainfall of that particular day. Now accuracy of this measuring glass, that is 0.1 millimeter. That is the accuracy. That means the minimum reading which can be stood out from this, which can be read out from this measuring jar. And Indian Meteorological Department, that is IMD, they have invented new rain gauge in this category, that is the fiberglass polyester rain gauge, which is the advancement over this. Now this was the first type of rain gauge, that was non-recording type rain gauge. The second type of rain gauge, that is known as the recording type rain gauge. Now these rain gauge also provide the valuable information regarding the intensity of the rainfall, which was lacking in the non-recording type rain gauge. That is sorted out here. That means intensity is also calculated. Now these recording type rain gauges, they are of following types. The first one is the tipping bucket type rain gauge. Now what is this tipping bucket rain gauge? So the water that will be falling, that is passed through the funnel into the bucket. So let me just show you. As you can see in this image, so this GIF is representing that the water, when it is collected into this bucket, when it is completely filled, it tips over about this pivot point. So there is certain pivot point which is present here. So the water is allowed to fall into this bucket through the funnel, and these 30.5 centimeter size rain gauge, that means this entire assembly will be packed in a rain gauge having a size of 30.5 centimeter, in which these two small buckets are located on a pivot point about which it is tipping over. So the water is getting collected from the funnel into a bucket, and when the water collected is 0.25 millimeter, that means when it is completely filled and it is 0.25 millimeter, then the weight of this bucket, it gets over, and this bucket tips over this pivot point, and this water that gets drained out, and the second bucket that comes under the funnel, and now the water will be getting collected into the second bucket. So the funnel then discharges the water into the second bucket, and when it be filled with 0.25 millimeter depth, then it will also tip over. So in this way the process continues. Now how can we measure the intensity from here? So this intensity is collected from the time required, because we will be getting the time which is required to tip over one particular bucket. So to tip over the 0.25 millimeter of the water, how much time is required, that will be calculated. Let's say that is 1 hour. So obviously we will be getting that intensity of the rainfall is 0.25 millimeters per hour, and in addition to that we also get the number of times a particular bucket is filled. Now these type of rain gauges, these are suitable for the hilly area, because one reason is that the rainfall intensity is more, so we do not need a person to empty the bottle which is receiving the water, which was required in the Siemens rain gauge. So that is removed here. The second advantage is that the process is automative, so we do not need to go personally there to check every time whether the water is flowing over or not. That is the first type of the recording type rain gauge. The second type of recording rain gauge, that is known as the weighing bucket type rain gauge. Now in this weighing bucket type rain gauge, a bucket is kept on a weighing platform. So as you can see, this is a catch bucket in which the water will be getting collected from the funnel. Now this bucket is covered by this metal cover, which is placed on a spring balance, which is used for the weight measurement. Now the weight of the bucket along with the water content, that is recorded on a revolving drum. So this drum which is placed here, as you can see, this is continuously revolving in such a way that it completes one revolution in a single day. Now when the water will be collecting, so the weight of the bucket, it will be increasing. So because of that, this spring will be compressed, and this pen will be getting deflected in the downward direction. As you can see in this image, earlier the line was straight, and then because of the weight of the bucket, it has fallen slightly below, and now the line will be drawn according to this needle, and in this way the graph is plotted for a single day. Now what is the advantage in this? So in this particular type of rain gauge, this bucket capacity, that is very high, and because of that the rainfall that is getting filled in here, that is accumulated rainfall. Because if in the first hour, let's say 10 centimeter of the rainfall that was present, in the next hour 5 centimeter of the rainfall was present, in the next hour the 3 centimeter of the rainfall was present. So after 3 hours, if we check, so we will be getting 18 centimeter of the rainfall, and that will be present in this bucket. So in this way we get the accumulated rainfall versus time graph on this chart paper, and this curve between the accumulated rainfall and the time, that is known as the mass curve in hydrology. That is the second type of the recording rain gauge. The next type of recording rain gauge is known as the natural siphon type or the float type rain gauge. This is the most widely adopted rain gauge by Indian Meteorological Department. Now what it does, it collects the water from the funnel. Again, the water will be coming from the funnel, and it will be entering into this float container. So this is the float container in which a lighter material is present in the form of the float. Now when the water will be filling over in here, then the float will be rising up. Now the displacement by which it moves over, that is recorded over the graph. Now this graph is again mounted on a rotating drum, and when the float container is completely filled, so this float will be coming above, then it is emptied by the natural siphon action, because of which the name comes as the natural siphon type, and the graph paper is automatically reset. Now obviously in this case also we are again getting the accumulated rainfall versus time curve, which is known as the mass curve. And you must remember that this is the most widely used recording rain gauge in India, which is recommended by the Indian Meteorological Department. And the most widely used non-recording rain gauge, that was the Siemens rain gauge. So there is a difference between the two. Now in addition to these recording and non-recording rain gauges, we are also having the latest technologies which help in getting the rainfall intensity and the magnitude of the rainfall. So the first technique is regarding the radar, which uses the pulses of the electromagnetic waves. Second one is the use of the telemetric rain gauges, which are used to collect the data about the rainfall. And in addition to these, we are having another method which is known as the remote sensing. That means using these satellites. So these are all the latest methods which are developed to get the data about the rainfall. This completes the discussion regarding the measurement of the rainfall. In the next video, we will take a look at how do we calculate the average rainfall from the particular area. Thank you.